Hello, it's Don Burrell again. I had to redesign the rice hullers. These are hand powered or motor powered or bike powered because Stoltz no longer makes these, and I got requests on where to find a replacement. So I found some. This one, the diameter is quite a bit smaller, so we had to do a lot of reconfiguring on the chain and sprockets. I wanted to point out that in my research I tried pallet jacks. These are the steering wheel side, so they're larger diameter. These would be great if they worked. This one was a 95 durometer. This one was an 85 durometer. Too hard, too soft. You've got to be right around 90, and that's what the industrial rollers are. After I finish this one, I'm going to make one more video because these should always be available. This is a steel wheel. It's got to be flat here, not curved. And then I'm going to glue this polyurethane 90 durometer sheet to it. So what we're going to do is I'm going to hull some rice, make sure this thing works just to show you what you can do, and then I'll slowly take it apart, explaining how to build it. We're also going to have a website up in December of 2023. An individual has volunteered to pay all the costs associated with the website and to monitor it for us. So let me hull some rice. So I have some long grain rice here. Wish it was short grain because short grain is easier to remove the husks and we can separate it. Once I get this rice started, so we're expecting to get between 70 and 80%, maybe 85% if we're lucky during the first pass. I'm going to try to speed this up a bit. That's a lot of load there. But there's the rate that I would prefer to be at. I'm going to feed it one set at a time. Rice that is thinner than other rice is not going to get hulled. Also, the thinner ones, a lot of them are immature, and you'll never get the husk off of those. If this thing was full of rice, it would be pushing it down more. Alright, there's one pass. Here's the rice after the first pass. And this is in the, excuse me, 70 to 80%. We're going to run it through again. Here's the second pass. There's, I noticed in here we have the immatures, which means they didn't fully form, and you'll never remove the husk on those. Now that I have very little volume in here, I have to push it in with my fingers. Here's the rice after the second pass. This is about what I would expect. This is in the high 90s. I'm not going to count them out. Here I am doing a half pound of rice. I wanted to see how long it would take to do a half pound. So this is the rate that I would expect people to be doing it at. Nice even flow coming off the top. So the half pound of rice took 1 minute 30 seconds. So to run it through twice would be 3 minutes. So that's 6 minutes a pound. So that's 10 pounds an hour. This is the half pound that I was running. I'm going to run it again. We want to see if we get the same hulling rate as when we did it with just a few grains of rice at a much slower speed. Hopefully it'll come out the same. I believe it will. We're going to flow it through here pretty fast. Right, so this is the rate that we expect. And then I'll winnow it when I'm done here. This is not cut away. This is the entire process of doing this for the second time. And again, I'm starting to run out. This is the rice after 2 passes, half pound at the rate of 10 pounds an hour. It's probably in the 90 percentile, so that's good enough for us. The hulled rice is probably double layer, where the unhulled sticks out. Now we're going to start breaking this down. This was the old system with the Stoltz rollers. Everything was much bigger, and now we had to bring everything in closer together. The first thing I'm going to do is this hopper. We'll start at the top, work our way down. Inside here is the feed roller, and the important thing about this design is to let the rice flow over the feed roller at the rate that these pinch rollers can handle. We do not want to overwhelm the pinch rollers. That was the big concern, and that sort of is what's unique about this system. So in order to do that roller, we have 2 sprockets. These 2 sprockets happen to be the same number of teeth, 19. So whatever rate the slow roller is the same rate that my feed roller is. If you're going to switch over and use a bicycle powered or a motor of some sort, which will go much faster, you need to slow this one down quite a bit. So you might want to change these to 50%, like this could be 20 teeth, this could be 10 teeth, something along those lines. I don't think you can get 10 teeth, but let's say 12, 24, something like that to slow this down, and I can't tell you what that actual number should be. So we're going to take this guy apart. Before we take this apart, I'm going to zoom in on these pieces of paper here. They are are about the rollers and the parts. At the end of the video, we'll lay out all the parts. So this is what I bought on Amazon back in August of 2023, not knowing that there was only going to be this one I bought, but others had purchased some, and hopefully it'll come back available on Amazon. If not, this is the company that you can buy them from. They're meant for their metalworking equipment. They're $40 a piece. This over here, this is the material and the price list. And then this is the information on the website. Now we'll start taking the So I've now removed this piece of plastic that was our window, keeping the rice from coming out. I've removed the drive sprocket. We use these aluminum pieces with the slots cut out in them. Now when I remove this side, I'll leave the roller there. What we have is rice piles up in here. This is my gate that I open and close. The critical thing here is that you have this gap in here. This is about ½ an inch to an inch. And rice piles up here. If this ramp is too close over here, especially if it's right up against it, too much rice will come over. You want it to pool there first. This is my gate. I have a slot. This is a 1/4 bolt that I'm using. You drill this hole in the wood 5/32, and then you can just thread right into that, right into the wood, as long as it's smaller than the 1/4 inch. This ramp here is attached here. Let's see if I can take that out quickly. So this has this plate here, which was holding our gate. You just pick this angle to be pretty steep, then you put a screw on each side. This has to match the width of the rollers. Let me take that off. This piece I'm taking off, out of convenience, to make it appear to be easier, I screwed it directly into there, but as you can see it kind of bends this. Your other method is to draw a line here, put in a plate, and then attach this to the plate that you have sticking here. Some kind of a ramp comes down like that. Key here is this piece here. This plate is screwed in on this side with 2 screws. This piece here, I have the slots in them. I move this up so that the gap is no wider than a grain of rice. You'd like it to be smaller rather than larger. This is our drive shaft. I'll go ahead and point this out. This is a bracket that solidifies everything, and again I use these notches. Another point right now to make is the top of this edge here should be about the middle of your shaft. Middle, not up here high, just right in the middle would work. Then I'll show you how we made these. These are drum sanding that would be on a spindle, so these are 1 inch 36 grit. And here's another one. So 3 of these do it. And the way I did this was these are 1/2 inch shaft collars that have a 1 inch outside diameter, which is really convenient. It just slides right on. I had to put a little bit of tape on my 12mm shaft to get these centered, and then I just screwed these down. If you find that these might be a little loose, you could just put a little bit of adhesive in there to lock that down. These all have a grind spot for my bearings. So here's our sidewall. It's on top of the other sidewall. These numbers are very difficult to see, but the middle of this bearing, where the shaft's going to be, is approximately 1.5 inches. But then I said, well, let me give you a different set of numbers. So if you put this on there, from here to here, this edge is 1/2 inch. And then this one, from here to here, is 2 inches. So this will give you this angle. We want this to be lower so the rice doesn't have to fall as much. And when it comes over the top, it needs to fall in between the other 2 rollers. So that's why this is where it is. All right. So you come in here, you drill this out for your 1/4 inch hole here, 1/4 inch hole here, and then here, this is probably a 5/8. You can use a 7/8 if you'd like. This is just for clearance for the shaft to go through. So once you've made this first one, you take the other sidewall, you line it up. The top's not important, back's not that important. The bottom is, and then these should be relatively flush. You clamp these together, screw these together, however you do it, and then you drill these holes down into the next one and this one to the next one. And you can see here that actually I drilled this hole, something messed up, so I had to go in and clean it out to get the shaft through it. So these are the ramps that were inside. This is the ramp, this is the gate that were like this. This is some kind of a particle board with this finish on it. But if you don't have access to that, you can get one of these cheap clipboards and just cut your pieces out of that. You have a nice smooth surface to work with. These match the width of your hopper. In this case, we're right around 3 inches. You want to make sure that you don't jam things, so put a little bit of clearance on here. And then this one is the one that slides up and down. So now we're going to start disassembling the actual dehauler. As you can see, this was the Stoltz, and the rollers are this wide. So I had plenty of room for a chain in here and the sprockets, and my gap adjusting was here with a spring here. But now that I'm using these much smaller rollers, we had to make this change. So I had to go with these smaller bearings that are nice and small, but they come in metric, so they were 12 millimeters.
So we had to do 12 millimeter shafts, and now our sprockets are matching those. This sprocket here is 12 teeth. This one is 24 teeth. This one will go 50% the speed of this one. These are idlers, and this is a 12 millimeter bolt that you work through here. The chain, when it's going like this, is pulling here, here, here. So it's initially pulling this way. As the rice goes through the slot, the friction between the two surfaces and the rice is attempting to speed this one up to the same speed as this. And the chain, in fact, keeps it from speeding up. So it always stays this constant speed a little bit lower. So the gap, because this distance here is so small, I opted to put a bracket at the bottom and a bracket at the top. We'll show you this in detail, but this screw here, this bolt here, this nut rather, moves. This will set my gap, and then this two springs combined is the load. Now if we pull on it, it'll just open up just a bit. Right there is about the width of a grain of rice. It's never going to open up that much. The polyurethane in here will give also. So I'm going to remove these. We can talk about the handle. This particular handle has a rectangle in it, and as you'll see later in the video, I ground this off. These are case hardened, so they're not easy to work with. Let me take these off. Before I do that, I'm going to show you how we set this gap. This light you see here, this is the gap. I put the light underneath so you can see it. So this is a hacksaw blade. Give me an idea. So it just touches. And when I turn this, you'll see at one point it gets very tight right here. And what will happen is this area here is going to wear down. On the commercial rollers, which are 10 inches in diameter or more, they make the roller and then they use a lathe to make sure that it's true. We don't get that opportunity, so we're just going to do this. It'll wear down a little bit. These are 90 durometer, so the rice will indent into it a bit. So let me drop some rice in there. So I just put in those 3 kernels, and there they are. Now I'm going to run these through the huller. I'm going to take this one, and this is the fast one. So it just hauled those rice that came out somewhere, probably sitting on my phone, which they are. And they got a hold. So zoom back out. So how do we adjust that gap? So over here and over here we have the number 8 by 2.5 inch long bolt. This is fixed on this end. This is the adjustable one. It moves in and out. This one that the wrench is on is not a typical nut. So it's typical on that side, but then it has the plastic insert, and that keeps it from loosening while you're hulling rice. Otherwise it will move. I had that experience. So if you watch this gap here, if I turn these, I can bring this side together, and this thread is nice and fine. So there it goes. Now I've just moved it in. Then I can move this back out, and I'm going to try and get both of them moving. And if you see that it doesn't move when I'm turning this one, there it goes. And I'll turn this, and now I've still got that spot there. Let me move this out. Now, if I pull on this, try to separate these two, except I can't really grab it. You'll see how that moves. That's when the rice goes through. If the spring just allows it to stay in close proximity, and then the rice itself indents into it. You certainly don't want a gap in there that would allow the unhulled rice to fall through. So now we're going to start breaking this down. Remove these. Now I've already loosened these, so this just comes out. Here's the two halves. We'll do this one first. So on the back side of this is a plate here that's screwed into just one side, and then with these notches I'm able to slide this in to stop husks and rice that's stuck to this from coming back in. And now I'll open these up by loosening these, and we'll take a look at what's inside. This is the side that's not attached to the base, so it moves. This obviously not very much, moves the millimeter or so. This is a foam pad on here. This fills in the gap. As you can see, I have about 1/4 of an inch right here, and this is a weather stripping for doors. It's got an adhesive back on it, so it makes it very convenient for filling the gap. Also on this one, since it's not attached to the base, you have to have a back plate on it to stabilize this. The bearings are locked in here, so they control this width. Back here, you just want to lock this in. Let me take that off. Again, we use the slots because that makes everything much easier to align. These are the 12mm bolts. We had nuts on there earlier. These hold the idlers. I'm going to pull this apart. So this is the one where we can have this attached here, and I make it so that it doesn't hit the other side, so I don't have to cut it perfectly. Then I take this, cut it a little short, and then this moves into where the roller was. So here I can see where I made some mistakes. So make sure you know which is inside and which is out. We'll do this alignment later because we're going to use the template method just like we did on the hopper. This is the roller from the other side. Looks like I still need to loosen a screw here. So this is the roller with the shaft, and you can see how much smaller it is. This smaller diameter actually also makes it harder for the system to hold the rice. The larger diameter, you'd actually have more surface area contacting the rice. So now we'll take this one apart, take these off. So but this is the two sides of the holder, the side that moves. I wanted to point out these are these 12 millimeter bolts. They're 75 millimeters long. That's from the underside of this out to here, so that's about 3 inches. You want to make sure they're fully threaded. So here's this piece, just like we did the hopper. We want to make sure that the bottom, these are both perfectly aligned. This is the front edge. So you want these and these to be set so they're identical. And then you can bolt these together if necessary once you're ready to do the bottom. So this, I put this on here from the bottom up to here, the bottom of this, 4.5 inches. If you're off a little bit, really doesn't matter. We have this high like this because there's going to be a angled plate to drive the rice off. So you're going to put this gap right here is about 1/8 of an inch. That is so as I put this roller on there, it's going to stick out away from the wood, and I use about 1/8 of an inch to 1/4 of an inch. So you drill these two holes. This hole here, this is a 1/2 inch hole. I've got a 1 inch down from the top. This distance here is not critical. Let me do a measurement. Looks like it's about 2 5/8 from this end. Then this one, the middle here, is about 3/4 of an inch from this edge. And the way I do this is I drill a hole here, drill a hole here, and then cut in between them. I actually use just one of these little hand saws like this. Somehow you're going to have to get in there and cut that out. So I've drilled these holes, then I use a bigger bit. I use I have a set of Forstner bits. These aren't as expensive as one would think, and you can get a smaller set. And then I use the one that I think will clear 5/8, 3/4, 7/8, because this really doesn't matter. All you're trying to do is give it clearance for the shaft. So I've done these. I lay this on the top, drill these holes. This is the outside over here. Now on the inside, you can see I did these by hand with the Forstner bit so that my 1/4 inch bolts drop in and are flush with this surface. Now you can also use, these are called carriage bolts. They have this other look to them, but they're still almost the same thickness. You can pound these in and then get them flush also. And that is pretty much it for the sides. Now we'll move on to the other side that's fixed. On here we have the roller. This is the drive roller. We've ground this down. I had to use the abrasive wheel to cut it. Hopefully you'll be able to find shafts that aren't case hardened. But this goes on here. And then these are shaft collars that are for a 12 millimeter. And we put those on either side to stabilize our handle. So now I'll discuss these right here. This is our system for setting the gap in the spring. So we've taken aluminum, this is 1/8 inch thick, cut notches in it. Easy way to cut a notch is drill a hole at the bottom, take your hacksaw and cut to it. Then I've put 2 holes here. On this side, again 2 holes. You want to make sure that this is wide enough so that your holes clear this spring action and the bolt, so you can screw these in easily. This goes in and out, so you can see I can move that. Now since there's 2 springs on here, they add up to the total resistance for the rice as it passes through to move the rollers apart. Now what I used was, these are for 3D printers. These are springs that the number 8 will fit through, and I don't know about their quality control, but I started off thinking I would use this red one, but it was too stiff, so I moved to this blue one. You can buy this kit, they're $17, something like that, or you can try to buy them individually, but I bought this because I didn't know exactly what I was going to need. And the other thing that's special to this are these rollers, so I'm going to splice in now a video I made much earlier showing how we epoxied these. And again, the question is, how do you know where it is? You put it in here before you've epoxied anything, setting how much you need set out for your sprockets. In fact, this one here is flush. This was a mistake. This should have stuck out, because you don't know if you're going to need to put something here later. The other thing is, when you go to pull it to test your spring, because I make sure that I can move this. If I can't move it, my springs are too tight, move the 2 halves apart. Or sometimes it's just way too loose. So now we're going to cut right to the older video of me centering the shafts. So we have this, the diameter in here is 1 1/16 inch per their instructions. So these black couplers, this one is a 2-part. When it is set on a 1/2 inch shaft, there's little gaps here and here, it fits nicely in here and will center our shaft. So what we have to do is take our 12 millimeter shaft and add something to it to make it a 1/2.
And what I'm going to be adding is just some tape. So I've marked on here where the roller is going to go. And I've also mounted it in the huller so I know where the grinding should have taken place. These shafts that I bought are for linear transmission. So these are case hardened, and if you have a file, it's harder than the inexpensive files. You can't cut it with a hacksaw. The only way I can cut it is with one of these abrasive wheels. It's a cut-off saw. And then once you have this, you can remove the metal where you're going to put the screws for the sprockets. And then right here, if you can see that, I cut notches out because we're going to be putting epoxy in there and to keep this thing from spinning. So it's going to be going in here like this. Now for the epoxy is going to go on here, but I want to make sure it sticks here. So I'm going to take this drill, this is like an 1/8 inch bit, and I'm going to just punch some holes. And I probably won't, I'll probably edit out some of these so you don't waste too much time, but I'm just drilling. So now that I've done that, clean this out. Now I have these 2-part clamps that I'm going to put on here, and this, where this is notched, my clamp's going to go in here and here. So I'm going to put a layer of tape. And you don't have to be that precise. So that's already too big. So I'm going to remove some of this tape and get it down to just one layer. If I can find my razor blade. I'm going to put one layer of this duct tape on. So one layer of tape. The way I can figure this out is I can look at this gap here, so I can know approximately what I want these to end up being. So there's one layer of tape. You know, I think that's going to do it right there. Take my Allen wrench. Screw this in. Take this one, screw it in. Well, I'm compressing that tape right now, and this is adhering this sleeve to the shaft. Now let me check this and see how that is. Okay, so that is going to fit snugly in there. Now what I'm going to do is I'm going to grind off these heads so that everything will slide in easily. I have to do this for the other side. So the key here is that this is an easy way to center your shaft. Now if it turns out this duct tape is pretty thick, if you needed thinner tape, if you were using thinner tape and you wanted to add a little, I just could add it with a little bit of Scotch tape, because we're just using these as pure compression. So I'm going to cut this. I'm going to do the same thing on this side. Alright, so I have one layer. I feed this in. And by using the 2-part one, I don't have to try to press it on. Initially, I was using one of these that's called a split, and if I got this tape on here to a half, then when I went to push this on, it started pushing on the tape and would bunch up and cause problems. So that's why I switched to this one. In fact, this is the first time I've used this because I keep buying things that I believe we need. So once you get this on, if you grind these down, you're not going to be able to get this back off without cutting it off. So make sure that it works. So I'm going to grind these off. Okay, I've just removed the screws on here, so these are now flush, the heads are flush. So now, one of the reasons I do this clamping method is going to allow me to push this through. These, the ones that are the cut ones, they're not a two-piece. These would mess up the tape, and I'd try to work on a system to get around it. This shaft collar is the one that we're using for our sanders, the sanding sleeve that's going to feed our rice. It's 1 inch in diameter. Again, making it easy to center this. The only reason we're doing this is to make this easy to center onto our shaft. This is the idea, is that we want it nice and tight. So I have a mark here, a mark there. I need to go down just a little bit more. And again, when you've done this, you've made this pretty precise. So now I'm going to fill this cavity here with the epoxy, and I don't even actually have to fill it all the way. What I'm using for that is some of this epoxy that comes in a pump. So one of these pieces of putty stick will do both rollers. You use about 1/4 of it per end. So now we're going to just knead this until it blends. Okay, now I'm going to push this down in here. So I want to make sure that some of it's going to go into those holes. It's also going to be up against that shaft with the notch in it. Once I get this one done, I'll do the other end. And then this becomes one solid piece. And you know, I looked to get drive shafts that weren't case hardened like these are, but I wasn't able to find any. I'm sure they're out there, but I didn't see them. So I'm trying to get this in. If there is too much of it, which is what that appears, I'm going to remove this excess. Go there. This one I did a couple days ago, solid as can be. Okay. Here are the parts for this rice huller. The clipboard is what we use for a couple of the ramps. Here's the plastic. These are the various pieces of wood. These screws here, these are all these pan head type screws that you're going to need. These are the 6 bearings. This is some 1/8 thick
1" by 1" right angled aluminum. I think I bought a 2-foot length of that. This is the adhesive we used for the rollers. This wood here are the various sides and the base for the rice huller. This is the foam that we use between the two halves to keep the rice contained. These are the two rollers with shafts in them. Inside there are these split shaft collars for 1/2" collars that are now 2 or 4 of them are inside here. And then they have the epoxy in them. This is miscellaneous. You need a lot of the 1/4" nuts and bolts, and then a bunch of wood screws. Let me go back over here. Here's where I've cut up the aluminum to make the little brackets for holding the sides. This is a number 12 sprocket. These are all with 12mm shafts or a bore in them. This one's 12, 24. These are the idlers. This is a 12mm shaft with the 1/2" shaft collars on them. They're a 1" OD, which is the ID of these 36 grit sanding sleeves. These are the 2 sprockets, same amount of teeth. I believe these are 19 for the drive on the hopper. This is the number 25 chain for the hopper. This is 25 chain for the huller system. These are the gap setting with the springs. I wanted to make a note. See this little nut right here? It is not a normal one. It's threaded here, but on the other side it has a plastic insert. You're going to need that right here, or these will loosen up on you. These are the springs. We ended up using the blue one. These are for 3D printers. This was our winch handle. And then these are 12mm shaft collars that we use to stabilize that. There it is. We will have the website up and running, ricehuller.org, sometime in December. There will be written information, plus we'll have an email address. People could contact us if they need some help. Good luck with your rice huller building.